So thanks, Shane. Today, I'm going to be showing all of you some maps and data also on movement and mobility, just like Anita did, but on a slightly different time frame and in a slightly different context. This is from a project I've been working on for several years as a consultant. I'm just going to turn off my camera if I can. Sorry about that. Okay, technical difficulties. A project I've been working on for several years as a consultant with Gordon Darroch from York University and Haydi Wong, who started out as a research assistant and now is a senior planner at York Region, just north of Toronto. I first want to acknowledge that the population we are studying is a colonizing and settler population, and recognize the rights of a number of pre-existing First Nations populations to this territory we now call Ontario, Canada. This is our project study area. It's the central part of the region of Southern Ontario in 1861. In many ways, this study area is not ideal. A larger area, such as the whole province of Canada West, as it was known at the time, for example, would have been better. But in other ways, the area was ideal for historical investigation of migration. It was still undergoing settlement, expanding the extent of farming, and experiencing the churn of immigrants and their families searching out their destinies in the late 19th century. What Gordon Darroch and his colleagues did in this project is create a database of about 5% of all the individual data records from 2 censuses in this region. He sampled households in 1861 based on a random selection of names of household heads, and then tried to match the individuals in these households to people of the same name in 1871, corroborating identity by age, religion, etc. Based on these linkages, we can see if people were stayers or movers within the region. We can map their locations in 1861 and 1871 to visualize origin-destination migration flows. This map shows the entire population sampled with larger green proportional circles and the linked stayers and movers as smaller pie graphs within the large circle. Overall, we were able to link about 35% of our records with a high level of confidence. Of these linked records, 29% of them had moved locations and 71% had stayed in their own location, their original location. We believe this actually understates the amount of actual movement of people, as many were not linked but still may have moved, not linked due to a number of reasons. The last names of women changed by marriage, people dying, or people moving entirely out of the region. You can see from the map that there is lots of variation in the proportions that are linked and in the percentage of stayers and movers across the region. This reflects the different local circumstances. An area where there was a lot of growth or a lot of stability, or an area hospitable or not to individual families or cultures. I've been fortunate to work with a researcher who has been very open to experimentation with GIS and mapping to inform his research. What I'm going to show you today is not necessarily finished product, but the result of our design experimentation. We took his working assumptions and tentative hypotheses and tried to use migration flow maps to explore these and provide feedback to formulate new ideas. The maps should be able to show volumes of movers, path and directions of movement, and to isolate subpopulations to compare patterns of movement and map these against underlying characteristics. That's what they should be able to do. But that's the theory. This is the reality. And this is the challenge that we were faced with once we figured out the basic methodology of mapping origins and destinations. How to extract meaning from what appears to be a confusing, overwhelming cacophony of migration flows. But as we just heard in the keynote presentation by Anita Grazer, there are lots of possible approaches to bringing order out of what may appear to be the chaos of data. Over many years, there has been quite a robust literature on design and visualization of flow maps, looking at the twin goals of visualizing overall patterns while maintaining detailed data on demand. Graphic cluttering is obviously a challenge. The occlusion of lines, dealing with salience bias, which is a perceptual issue, and the complexity of the resultant map images. There are different approaches to deal with this, emphasizing graphic design, emphasizing statistical summarization, or combinations of these to deal with these issues. Here are some examples of possible approaches combining graphical and statistical manipulation to visualize migration flows. An article by Jenny et al. Surveyed a large number of published flow maps and used content analysis and user studies to put forward a series of design principles to follow in creating flow maps. Wong and Zhu have written about how to select primary flows, smooth and combine similar lines, and map them effectively. And Anita Grazer and her colleagues have championed and developed the edge bundling approach to consolidate and simplify major trends in complicated flows. But every situation in cartographic design is somewhat unique. The next few slides show some of the cartographic design experiments we undertook. For example, we started looking at edge bundling and found that although our first attempts did show some promise in producing visualizations of overall migration patterns, the methodology did not retain the visual connections between specific origins and destinations that we needed for detailed understanding of intra-regional movement. We ended up spending a lot of time, on mapping subpopulations and creating customized base maps to view as background to help understand the patterns. This is a map I presented at our conference in Prince George a couple of years ago. Here we show flows of migrants from families of Scottish-born household heads over a base map of census subdivisions grouped by the percent Scots population already there in 1861. This was helpful in visualizing the attraction of existing migrant population centers to new migrants. And we used overlays of subpopulations differentiated by color to compare patterns of migration flows between them. Here we're able to depict Irish in green and Scots in blue arrows and get some idea of where and how the different culturally related migration patterns emerge. But we ended up going back to one of the earliest writers about migration flow mapping for inspiration, Waldo Tobler, who was at the root of so much of what we now recognize as GI science. Tobler's list of publications is impressive, and several of them focus on migration flow mapping. One of the ideas he suggested in 1987 was to avoid arrows crossing each other by allowing movement to take place only between geographically adjacent places. In this example, simplifying the visual display by breaking up the long, overlapping cross-country arrows into shorter ones that show aggregate flows from state to state. Tobler's solution in itself would not solve our challenge of maintaining connections between origins and destinations sufficiently. So we decided to adapt his solution, not by mapping aggregated flow, but by routing flow lines along a network of paths rather than straight lines from origin to destination, to try and impose some order and avoid crossing over lines on the clutter of the multitude of overlapping crossing lines from the straight line maps. Unfortunately, we couldn't figure out how to do this in any single GIS package, so we came up with a method combining tools from ArcGIS and QGIS in order to create a network between all the centroids of census subdivisions and map the unique paths between each origin and destination flow in our set of migrant families and individuals. So here was our original map of all the migration flows. And here's what we ended up with, forcing flows along our network. Super simple by comparison, right? but on second thought, also rather misleading. We realized that routing all the paths along the network had just seriously worsened the problem of line occlusion, that is, overlapping lines above, obscuring those along the same path underneath. Even layering narrow lines on top of wider and maintaining the spectrum of color differentiation only addressed this problem superficially. We were only seeing the main one or two migration flow arrows along each path, even though many coincident lines may be hidden underneath. And flows going in opposite directions will also lie on top of each other. So we experimented with a number of graphic design adjustments in order to try to fix this issue. The first was to seriously widen the thickness of flow lines all throughout the spectrum, which made it easier to see those on top of others. The next was to apply an offset value to each line, equal to a bit more than its thickness, which had two beneficial effects. One, it moves lines off the center line a specified amount so that wider lines appear beside narrower lines. And two, because lines are coded topologically, including direction, that is from and to arrows or nodes, lines flowing in one direction are offset to the right of the central line, and flows in the opposite direction are offset to the left. So directionality of flow is now visually retained. You can see a clear example of this in the top right-hand corner near the legend, where purple and red lines follow the same path in opposite directions. However, even with these adjustments, line occlusion still exists, and the overall volume of flows is therefore underrepresented. So we decided to create a base layer of total aggregate flows along the network. Doing this, we lose the characteristics of directionality in individual paths, but get a much better visualization of the overall volume of migration activity. So here we have the map showing total flow lines by the number of movers and direction overlaid on the total volume of movers. Drilling down into this, our researchers can look at different parts of the study area and see different individual flows in the context of overall total migration activity. Using the network flow-based flow method can also be applied to mapping segments of the migrant population. Here we take the comparison of Irish and Scottish family migrants we showed earlier, but we use the network flow method for visual comparison. So we find there are some advantages, but some disadvantages to using the network-based method. The overall visual clutter is definitely reduced, and similar paths may be easier to discern. But the visual impression of the distance traveled, how short or long the lines are, which was previously apparent in the map in the top left, tends to get lost when forced along the angling network paths. We also wanted to do some analysis of migration patterns separated out by urban-rural categories. There was a fair amount of movement between these categories, but obviously more in and out of rural townships than anywhere else, as that's where most people live. Which is why I'm going to show you the maps of urban migration first. Much easier to absorb.
1 minute, Byron.
So we did a series of maps showing migration into cities, from other cities, from towns and villages, and from rural townships. Here's the simplest one, showing migration flows within and between the two cities in our study area. The next map shows migrants coming from towns and villages from throughout the study area into the cities. It's interesting how most of them come from towns close to the cities within their immediate hinterland. The final map of in-migration shows migrants coming from rural townships. Again, as one might expect, many more from close by than from further afield. Most of the far-flung in-migrants are single movers. Looking into it, many are young people moving to the city to find work. And finally, all the migrants into and out of the cities can be mapped, giving an interesting visualization of expected and unexpected urban interactions within the study region. So that was looking at the simplest case, migrations to and from the cities. Here's the combined map for all migration moving into and out of rural areas. And of course, it is most of it's from one rural township to another. much more complicated and busy. But again, we can glean information about this from this about where folks were going in their greatest numbers and generate hypotheses, then dive into statistical analysis for corroboration of these ideas. We're now working on the challenge of interpreting these patterns and figuring out how to publish our results without having to do a 50-page atlas. So thanks for following along with me on this journey along our meandering route of cartographic design experimentation. I hope some of it has been useful. Thank you.
Thanks very much, Byron. So far, no questions in the chat, but I had a question. So right at the end, you said without having to put it into a 50-page atlas to be able to display all this complexity, have you considered using a digital or interactive online platform?
Yes, and that's a great idea. It really depends what you mean by publishing. Using online, and I've been involved with a number of online atlases or online projects which have published their research online, and that's a great idea. Quite often in the academic community, publication in journals is what counts for people. Fortunately, both the principal investigator of this project is retired, and I'm what I like to call semi-working. So not publishing isn't an issue particularly, although I'm sure he'd like to get a paper.
Thank you. Any other last minute questions before we move on to our next presenter? Well, thanks, Byron, for that presentation.